we're studying rational functions 3 and the n behavior. Yeah, that was over dramatic. Sorry. Anyway, here's what we're going to be checking out. We're going to be looking at the n behavior of these things. And really what it is what I want to kind of justify to you is that when we're looking at the end behavior of these functions over here, and you know what, I don't know if you can see that, so I'm just going to zoom in a little bit. There we go. Zoom that in. I know that that's a little bit too close, but it's all right. All right. Really, when we're looking at this 3x cubed minus 2x squared plus 5x minus 9, the values that really what we're looking at is where does this thing go in the end? Does it go up to infinity? Does it go to like a number, or does it go to negative infinity? And we want to search when x is a really, really big number or x is a really, really small number. So give me a second because Paint is trying to figure out what to do with me. Hold on, let me just fix this. I'm fixing this now. Okay, there we go. All right. But what I need to justify to you is if we're talking about x being really big or x being really, really small, then to be honest with you, it almost doesn't matter what these terms are. Okay. I guess maybe the best way to do this would be to make a table for you. Yeah, let's do it. Sure. Fine. Let's do it. Let's go to Excel, and we'll just try that out. I'm going to try something new. I wasn't thinking about doing it, and all of a sudden I was saying, that would probably be a good idea. Let's try it. All right, hold on. 1 second. All right, here we go. Now what I'm gonna do is I'm going to plug in some numbers and see what happens. Okay, do this, close that. All right, I don't care about that. I don't even know what it is. Here we go. All right, so check this out. Here's what I'm gonna do. I'm going to plug in a value for x. I'm going to do this is the function, and this will be another thing. This will be leading. And then this will be difference. Alright, so the function I want to look at here is the 3x cubed minus 2x squared plus 5x minus 9. So I'm just going to set up that thing. I'm going to put 3 equals 3 times whatever this number is cubed minus 2 times this number squared plus 5 times this number minus 9. Alright. And then I'm going to plug in the number 1, and I don't know, we'll just repeat that thing a couple times, so like 2, 3, 4, 5, 6, so on and so forth. And then over here, so I made a little table for the x that comes in. You give it a different x, it will give you the different y value that comes out. And I plugged in straight exactly that function. So let's try this thing right here. What I'm going to do is I'm only going to look at the leading coefficient. So this is equal to 3 times this cubed. Okay, good. I'll do a couple of these. Actually, I'll do a couple of all of them. Let's see. And the difference will be the difference between this number minus that number. Okay, let's do this. All right. So let's see. Let's try a few of these things. Let's try. All right. So as I get these numbers to be bigger, but I don't want to go just 1, 2, 3, 4, 5, 6. Let's go 100, 200, 300. Let's try 1,000. Or let's try 1,000,000. Let's try something with a lot of zeros. All right, here, you know what? Okay, yeah, there we go. So this is 1 with 19 zeros. It's that big. It's a huge number because we're looking at x at we're looking at x being really big. So we only want to know about the end behavior. We don't only want to know when x is really big, or actually for that matter really small. So maybe this number's small. And the point that I'm trying to make is look at these numbers over here. See, even when we get to 1,000, at x equals 1,000, the value that this thing is and the value that this thing is almost the same thing. The difference is, I mean, it's, yeah, you're right, the difference is a really big number, but like those values are actually really close to each other. In fact, if you come over here, this thing says, hey, the computer says the difference is 0. They're almost exactly the same number, and the reason being is because this x cubed term kind of dominates everything else. I mean, like 1,000 cubed or 5,000 cubed is way bigger and way more important in this function here than the x squared or the x or the 9 is. I mean, that's like Manini stuff or Peon stuff compared to like how important that x cubed part is. So whenever we look at the end behavior of these things, we kind of model this ax cubed as ax is about equal to, and I'm going to put a little squiggly line as for an equal sign instead of an actual equal sign, because that just means it's approximately equal to 3x cubed. And if I were to graph 3x cubed, the x cubed I know looks something like this. But really, I don't care what's in the middle because I know that the middle part's not accurate. It's the end game, the end points that are accurate. And so my answer to this would be, I would say that at the end, this graph will go up like this and it will go down like this. And if we want, we can actually go down to like desmos.com. Let's try that one. And granted, it might do something funky in the middle. It might not look anything like what we're doing in the middle. But what I'm teaching you here is how to estimate what the thing is going to do in the end. This is a really important test to be able to do, especially when it comes to calculus. And I know you guys are thinking, I'm not in calculus. I don't want to be in calculus. Well, it's going to help you think in a way that is kind of new and fresh, and it just kind of helps you dig deeper into this problem. So I'm sorry, 1 second. This computer stuff is taking so long. Don't worry, I'll give you double points for all of this. All right, here we go. So let's say 3x cubed minus 2x squared plus 5x, plus 5x minus 9. All right, so the point that I'm trying to make is I'm going to compare this graph to 3x cubed. And if you look at it, these graphs aren't the same. Obviously, ax, or this graph right here, is not the same as that. But when you zoom out, you can't really tell the difference. And you know that this thing shoots up to infinity on that side, and it shoots down to infinity over here. So I would say that this is a good way to kind of tell that end graph behavior over there.